Let us talk about fuels as our subtopic in the topic energy changes, not just generally as fuel. A fuel is a substance used to provide energy. When it undergoes chemical reactions, the energy produced in such reactions can be converted to other forms of energy. Fuels can be either in a solid state, liquid, or gaseous. For example, methane, propane, and butane are gaseous fuels. So gaseous, we can have propane and maybe butane. Liquid fuels, we can have paraffin and ethanol, and finally we also have solid fuels. And a good example of solid fuel can be coal. You can talk of charcoal. You can talk of wood. Those are the examples of fuels that we have. Heat of combustion is important to fuel engineers and those who deal with diet. Such people usually compare the heat energy produced when equal quantities of different fuels are burned. And this is what we refer to as heating value. Of a fuel, which is worked out by dividing the molar heat of combustion of a fuel by its molar mass. For example, one mole of ethanol burns to produce 1370 kilojoule per mole. 1 mole of ethanol has a mass of 46 grams. Therefore, the heating value of ethanol is equals to simply having the energy divided by the mass, and that gives 29.78 kilojoule per gram. That is what we call the heating value of a fuel, which is defined as The amount heating value is the amount of heat energy given out when a unit mass or a unit volume when liquids are used, or gaseous particles, or unit volume that is for gas and liquid, is completely burned in oxygen. Below are some of the examples of fuels and their heating values. So we'll have fuel heating value. The value is in kilojoule per gram. Charcoal heating value is 33. Coal 29. Wood, the heating value is 17. Ethanol has a heating value of 30. Paraffin, the heating value is 48. Methane has a value of 55. Propane, that is 50. And finally, butane has a heating value of 48. So those are the heating values of some fuels. Choice of a fuel. How do you choose a suitable fuel? The choice of fuel depends on the purpose it is to be used. And when choosing a fuel, consider the following. Its heating value, very important. Availability, cost of that fuel, how the fuel can be stored, environmental effect, and the ease of transportation. So when you are taking a fuel, you are going for fuel, then there is an alternative fuel to be used for that. Same purpose, then go for the one that is highly available. Look at the heating value. Look at the cost. Heating value, availability, and the environmental effects. Those are the first three important considerations, because you can look at the cost, but the availability of that fuel is not there. The fuel is not there, so the availability is 0, meaning you may not have the fuel used for its purpose. Precautions when choosing fuel, or precautions when using different fuels. Let's look at the precautions. When fuels are not handled in right way, they may cause death. So we can now list the following precautions. Charcoal stoves should be used in well-ventilated rooms. As you know, it will lead to release of carbon dioxide, which is a poisonous gas. Gas cylinders should be stored in well-ventilated rooms far from heat sources. Only certified cylinders should be used for gas transportation. Fuel storage facilities be located far away from populated areas. Then people should keep off from fuels spills from tankers. It is very dangerous. Vehicle engines should not be left running in closed garages to avoid poisoning by the carbon dioxide produced. Environmental effects of fuels. Fossil fuels such as coal and petroleum contain carbon, nitrogen, and sulfur compounds which on burning produce poisonous gases. E.g. sulfur 4 oxide, nitrogen 4 oxide, carbon 2 oxide, and sulfur 6 oxide. The sulfur and nitrogen oxide dissolve in water to produce acid rain, which wears limestone buildings and statues, corrodes iron sheets, leaches nutrients from plant leaves, leading to the death of plant, acidify lakes, leading to effect on the plants and animals. Generally, aquatic life is affected. Leaches mineral from the soil, leading to poor soil for agricultural activities. So, it is important to control the escape of these gases into the atmosphere, because we have seen the harmful effects the exposure of these gases to the atmosphere may bring. Carbon 4 oxide and unburnt hydrocarbon from fuels contribute to global warming. Which leads to melting of polar ice, thus flooding of low-lying coastal lands, and also unpredictable weather patterns and climate changes. Measures that can be taken to reduce pollution. Measures you can have: designing zero-emission vehicles, which are to use solar energy or electrical energy. Designing engines which are to use unleaded petrol engines, using unleaded petrol. Fitting catalytic converters, to vehicle exhaust system to convert nitrogen oxides to harmless nitrogen and carbon 2 oxide to harmless carbon 4 oxide. Electronically controlling the quality of air mixed with fuel to ensure more complete combustion to lead to formation of harmless gases. Another point, we can use adding of fuels which contain oxygen, and this will eventually convert the carbon 2 oxide to carbon 4 oxide. And finally, encourage the other means of transport, such as use of bicycle and electric trains, to avoid excessive use of motor vehicles that bring such pollutions. That is all about fuels.